Hello ELT132, this is Roger Young, and this video is about decoders. So I wanted to basically review part of the lecture we had last week when we talked about decoders. What I have here is a single output decoder, and you can see it uses an AND gate. Now, the question to be asked here, it's an AND gate, right? So the output is low all the time unless every input is high, or it's a 1. So the question to ask is, when will Y be high? All right? Now suppose, I'm sorry, I have to get this right here. Here we go. Suppose instead of an AND gate, I put an inverter bubble there. That would become Y bar, wouldn't it? So the only time Y would be low is when each one of the inputs are high. So the key thing to remember about decoders is a specific set of inputs, all right, whether they're high or low or a combination, is going to provide a specific output. All right, so let's just use this example. Let's just use this example as it is. So if A equals 1, B equals 1, and C equals 1, the output is going to be low, correct? So we have 3 inputs, right? Let's just draw them here. Why not? A, B, and C. Right, here we go. Let's call it Y bar. So what do we have here? For 3 inputs, you have different combinations, right? 0, 0, 0, right? 1, 0, 0, 0, 1, 0, and 1, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1, 1, and 1, 1, 1. All right? Now, what case is Y going to be low if we're using this example? There's only one case. This case. When they're all high, the output will be low, because remember, you have that inverter bubble. All other cases, it's going to be a 1. Now, let's do something. Let's go back to the way we had it, right? There's Y. Let's get rid of that little bubble there. Let's go back. Let's make it an AND gate, not an AND gate. So for an AND gate, I'm going to draw another line here. The output is known as Y, right? So with an AND gate, the question to ask is, when is the output going to be high? Well, obviously, it's only going to occur when all your inputs are high. So in this case, 1 would be here, right? All these other cases, it's a 0, right? It's almost, you can almost think of a decoder as a key, right? You're only going to make, in this case, you're only going to make Y high, right? The output's going to be high only when all the inputs are high. There won't be any other possibility. So what's going to happen? Suppose, let's change it. Put a little inverter there. Now I'm going to call this Y asterisk just to make it different for you, okay? And let's call this one Y with an asterisk. So if you want to look at Y asterisk, in what case is Y asterisk going to be high? Well, obviously when all the inputs are high. When are all the inputs are high to the gate? Well, it's going to happen when this is a 1, this is a 0, which means it's low, and this is a 1, right? Because you know when this 0, or low, goes to this inverter, it's going to become a 1, isn't it? So when that one case, where is it? 1, 0, look at it right here, right? So in this case, your output would be high. But all other cases, it would be low. So, for single output decoders, I hope this answers your question about them, okay? So if you're given a single gate, and usually it's an AND gate or a NAND gate, either one, they're going to ask you what is the code that comes in. What do the inputs have to be to have an output be a certain value, high or low, okay? So just use your logic and understand and go back to basic principles that for a gate, for an AND gate to output a high, all the inputs have to be high, right? Now if you have an inverter here, which makes it a NAND gate, if all your inputs are high, your output's going to be low. Otherwise it's going to be high, right? And vice versa for your AND gate. I hope this has helped you on understanding single output decoders. And the next video is going to be on multiple output decoders. Thank you.